Seventh grade, welcome back. This is week 11. We're going to be talking about different layers of the earth, both beneath the surface and above the surface. And in my personal opinion, I think this lesson should have come before we talked about the rock cycle, but this is how it was organized. So we're going to jump right in. For our learning target, we should be able to identify the evidences used to support the theories about Earth's interior. Okay? So, if we wanted to know about Earth's interior, well, it just seems simple. Why don't we just dig a hole? And sure enough, they did. They dug a hole. This was in Russia. From 1979 to 1992, the Soviets drilled a super deep borehole that reached 12,262 meters. That's over 40,000 feet. Just to see how deep they could drill. Just because they just decided to. Like some people say, why'd you climb the mountain? Well, because it was there. Well, why'd you dig a hole? Well, because we wanted to see how far we could go. And so this is known as the Kola Super Deep Borehole, and it is the deepest artificial point on Earth. Okay? If somebody told you to figure out what was inside the earth, what would you do? Would you dig a hole? Well, that's what they did. How could you figure out what is inside our planet? You know, they went down pretty far, but still, they were probably only about 1/3 of the way into the crust of the surface of the earth. So they didn't even make it down to the magma yet. So this is not a volcano by any means. All right. So what are some other ways we can figure out what's inside the earth? Well, scientists have figured out that they can use seismic waves. They can't use X-rays. They can't just take a picture of it with an X-ray like you might if you had a broken bone, but they can use seismic waves. Now, where do seismic waves come from? Right, from earthquakes. Geologists study earthquake waves to see the Earth's interior. The waves of energy radiate out from the earthquake's focus. These waves are called seismic waves. And seismic waves go different speeds through different materials. They change speed when they go from one type of material to another. And this causes them to bend. In other words, the wave arrives in a place other than where we would expect it to if it went straight through. So it bends. Some seismic waves do not travel through liquids or gases. They just stop. Scientists use information from seismic waves to understand what makes up the Earth's interior. So the properties of seismic waves allow scientists to understand the composition of Earth's interior. Another way that scientists have tried to use to understand the interior of the Earth is to look at other things besides the Earth. So scientists study meteorites to learn about Earth's interior. This is a picture of a meteorite. Meteorites formed in the early solar system, and these objects represent early solar system materials. Some meteorites are made of iron and nickel. They are thought to be very similar to Earth's core. An iron meteorite is the closest thing to a sample of the core that scientists can hold in their hands. Now, if you look at this meteorite, it contains the mafic minerals olivine and pyroxene. It also contains metal flakes similar to the material that separated into Earth's core, which was metal, and the mantle, which was ultramafic rock. Okay? Another thing we can look at is density. As you know, if something is more dense than what it's in, it's going to sink to the bottom. If a rock is more dense than water, it's going to go to the bottom. If it's less dense than the water, if a rock is less dense than the water, it's going to float on top. Well, the same thing works with everything else, not just water and rocks. Earth's overall density is higher than the density of crustal rocks, the rocks on the surface. So the core must be something more dense than the rocks on the surface, like metal, okay? Another thing that scientists look at is Earth's magnetic field. Now, because Earth has a magnetic field, what we know about magnets, what we know about how they work, tells scientists that there must be metal somewhere inside the planet. And that we know that both iron and nickel are magnetic. Now, do you remember back to the picture of the meteorite? What were the metals that they found in the meteorite? Right, iron and nickel. And they're very, very dense. So you remember density? Among all the other rocks, if there were iron, it would go down to the bottom. It would go to the center of the earth, I should say. Plus, if it were solid, if it were, solid surrounded by liquid like we think it is, seismic waves would act differently around them. So, let's talk summary. Different types of seismic waves behave differently in different materials. Their behavior can tell scientists about the material they travel through. Earth must contain metal. Its density and the fact that it has a magnetic field require it. And finally, meteorites formed early in the solar system. Therefore, they indicate something about Earth's interior. So, our learning target, that we'll be able to identify the evidences used to support the theory about the Earth's interior. We gave you 4 of them. Can you remember all 4 and how they help us understand what the interior is like? If not, feel free to go back to the video. Not a problem. You can do that as many times as you want. Or move on to the next assignment, whatever you need. Okay, we'll talk again later. Bye now.